You having fun? Anybody? Oh, come on, come on. Do it a little louder than that. I know this has been a lot more fun than that. Come on now. All right, I'll let you off the hook though. So I'm gonna get started. I know this is like worst timing ever because they're like, you know, giving away the last beer and the last TV or whatever right as my talk speaks. I'm gonna have to talk to Chris about that one. Talk about a bad slot, right? But anyway, if you looked at your book, you notice that I actually have two slots, one on a distributed fuzzer and another slot on CTF and quals and kind of that whole area. And what happened is that basically my slots got squished together, which is totally fine by me. I was like, hey, I'm flexible. However you want to set up the speaker schedule, I'm totally cool. So I'm going to just talk real quick at the beginning about a distributed fuzzer that the company I work for has been doing a little bit of work on. And come on in, come all the way up to the front. And then I'm going to talk a little bit about the quals and the CTF stuff. All right, so first you figured it out. I'm Jarod DeMott. I went to Ferris State for my undergrad. There's a Professor Jewett. There's a bunch of them right here, right? Yeah. Yeah, come on, let me hear from the Ferris guys. Yeah. I knew. Yep, that guy too. It's a really interesting story that I was Professor Jewett's, where'd he go? There it is. Student and co-worker. There's got to be a story behind that one. Yeah, that's he's still there. All right, so I'm not going to get into too much of all that sort of stuff, but just real quick bio. My first job out of Ferris was at the NSA, and I had a lot of fun there. It was a good place to start a career in the security, the whole defense industry scene. I kind of circled around and talked a little bit and helped write a book and do a bunch of stuff. And now I'm back with a company called Harris, and they're a big defense contractor, and they do all kinds of stuff that I have no idea about, like build satellites and stuff that I'm not involved in at all. But I'm in a little team called the Crucial Security Team, and we do all the normal security researcher stuff, forensics and exploit development and all that sort of good stuff. So I kind of bounce back and forth on a lot of internal, I would think of IRAD, internal research and development stuff. Help, you know, this fuzzer that I'm going to mention was kind of a idea that I had. I came to some people, management and stuff, and I was like, hey, it would be cool if we had a distributed fuzzer that was, you know, all virtual, VM based, and you could basically push a binary in the top and an exploit pops out the bottom, and you have this continuous pipeline of either, if you're coming from the security, the development side, you either have this continuous pipeline of actionable bugs that you can then go fix in your code, or this continuous pipeline of almost ready to go malware that you could use. One way or the other, right? Because it's kind of a similar end game, it's just a little different. Now, of course, no such system like that actually exists, right? There's nothing like that that's that complete, okay? But that's the dream. That's what a lot of researchers are kind of working toward. And so our little step in that direction was the first part, which is basically the creation of a large amount of bugs. Okay? So like you put in Word and out comes 10,000 crashes. So we don't have, you know, necessarily actionable stuff like I talked about, but you're sort of like a third of the way there, so to speak. And so from the Harris standpoint, if you want to kind of work on this whole software assurance lifestyle, what I originally called it cluster fuzz, but the marketing people decided that that was not a good term, so they changed it to cyber fuzz. Cyber fuzz is just one piece of that. There's a lot of other components in the IRAD department at Harris that they're kind of working on to help their clients and customers secure their code and whatever their goodie stuff is. So what I had kind of in my mind was sort of like from the top down, you configure a VM and you configure some fuzz runs. So fuzzing, by the way, is a dynamic testing technique to find bugs in software. So it's just kind of like, you know, mutating files is a common way. to fuzz. There's also other ways. I'm not going to get into all that because this talk is going to go over anyway, so sorry, I pre-apologize for that. But basically, you could go out to the internet, you could download, say, 1,000 PDFs, and then you can do what's called a min set on those PDFs, where you calculate the code coverage of each one of the PDFs and say, okay, I ran this PDF through Reader, and it covered this much code. I ran this PDF through Reader, and I covered a little more. I ran this PDF through, and I didn't cover anymore, so I don't care about that sample. So by taking these, like large number of samples, you figure out only these 100 out of 1,000 are really the ones I want to fuzz with, because they help me get the best code coverage. They're my minimum set, my min set. And then once you have, so that you have spidering, and then you have a min set, and then you have your virtual machine and your application all configured. Then you push that out. So we're sort of on that first step, that configuration, and then onto the run step. You push that out on, say, 30 of your 60 virtual machines, or however many you have, fuzzing Word, and maybe the other half are doing Reader, or whatever your applications are, right? Maybe they're specific to your organization, or whatever it is. Just kind of using generic examples. And then you get crashes. Well, you might get 10,000 crashes or 20,000 crashes or something like that. You really can't deal very well with 20,000 crashes, right? It's too much for you to go and look through and say, wow, that's a lot of crash data to go look through manually. So you have a bucketing and a prioritizing algorithm, and you can use a plugin for the Windows debugger called Bang Exploitable. Is a good one out there. None of them are perfect, but they help you say, okay, of those 10,000 crashes, there's only 10 that are unique. You just found the same one 1,000 times each time. So maybe there was only 10 crashes anyway, even though you found it over and over again. And of those 10, maybe only 1 or 2 actually look exploitable. So that's where you focus your human capital, right? And so that's the idea behind this cyber fuzz. And I was going to give a whole talk on it, so there's a lot of details that I'm not going to be able to get into. For example, I'm not going to go through how to use, this was our version 1 dashboard, because if you've got this fancy idea, then you need some sort of graphical front end to drive it. And they actually have real developers working on this project now, by the way. So one of the things you'll learn about security research is we're really good at going down in the bits and bytes and coding up shell code in assembly and stuff like that. But don't ask me to manage and run some big corporate development program, because that's not going to happen. So they actually hired some real developers and have them working on this now, and they have a version 2 dashboard. And it's just a way to start jobs and partition up the virtual machines and kind of do that whole thing. And so if you have more questions about that, you can email me or see me offline or whatever. That was my first talk, basically, in 5 minutes, just to give you a little taste of what that might have been about. The second talk I was going to give here was, I think I titled it, Why Even Losers Win at Defcon, CTF, or whatever. So Atlas, if you saw his talk earlier, was a great talk. He kind of just jumped right in and was deep diving on how to solve one of the challenges for the CTF quals. Defcon is not the only CTF in the world, by the way. There's lots of different capture the flag events, and if you're not even familiar with that whole concept, a capture the flag is just sort of a way to, it's like getting a college degree or anything else you do. It's just a way to sort of train. You're sort of training yourself, whatever. Football people have football camps. There's a Rockford game tonight, by the way, if you're a local person. Stuff like that. So hackers, we have sort of our boot camps too, and the CTF is really a great way to do that. It's better than taking some certified echo hacker things, better than getting your CISSP. It's just my personal opinion, by the way. Depending on what your role is going to be, actually, because it really depends, right? I mean, if your role is sort of policy making and all that sort of stuff, then those other things, have probably maybe more value. But if you're going to be down in the bits and bytes, if you're going to be sort of, really looking at low-level stuff, then these kind of competitions are great for that. So this is a screenshot of the DEFCON qual. The qualifying round is the top 10, or actually this year it was the top 12 teams or so got to compete in the event that happens in Las Vegas. So you have to be able to qualify, and there's hundreds and hundreds of national, local, and international teams competing. It doesn't look like you can read this right here, but in 9th place right here, there's a team called 6 Men Came to Kill Me one time. That was the team I was playing on. And so we qualified, although we didn't actually have to. They have this standing rule where if you were the winners in the previous year, you don't have to qualify, but if you have any sense at all, you'll still try and qualify, because the game just gets harder every year. Like I can see this becoming like an Olympic sport someday, where all people do is they train their whole life and career to compete at a capture the flag. You laugh, but I can honestly see it heading in that direction. Like it gets more and more competitive every year to the point where it's just crazy. Like, for example, Northrop brought a team this year, and they brought 30 or 40 guys, and they spent, I don't know, probably more than $100,000 ahead of time preparing and training their guys to compete in this event. So it's a serious event. It's not, the results, you know, are, because it's like any other game, it's not perfectly run and stuff like that. So I don't know if necessarily being first or second is so serious, but being able to qualify and going there and training and competing and just having the experience of playing in these events is treated fairly seriously by more and more companies that want to be sort of known and as like ninjas in the cyberspace or whatever. Which again is why they call it cyber fuzz instead of cluster fuzz, because apparently anything with the word cyber in it or around it is better than those other words that don't have that word in it. So, okay, so if you noticed, by the way, I should go back real quick. There were different categories of, so you could say like the board maybe starts out with just binary leakness 100 open. And so that's the only challenge you can work on. And so the point of the quals is just to solve each question as fast as you can. You get points for each question, and the teams with the most points get to go to the final round. So that's how that works. And each category is a little different. And the interesting thing is that the qualifying round is really different than the actual event. So to qualify, you need a pretty diverse team. You need people who are good at forensics. You need people who are good at, you know, trivia sometimes even. Like one of the retro questions this year is one that's always there. It's always blank the planet, or just hack the planet, or it's hack the blank, or something. So they always have like one really, really super easy. Most all the questions are extremely hard in my opinion. A lot of them take multiple people working for multiple hours to solve, but they usually throw in one or two really easy ones, stuff like that. And so that's totally different than the actual event, because when you get to the actual event, you don't really need forensics people and stuff like that. It's a different game altogether. So what do some of the challenges look like? Well, Atlas went over the Pwnable 500, so you got a sense, if you were in his talk, you got a sense for what that was like. The Pwnables are usually like, they've had Windows, usually Linux or BSD, some kind of service running on a port, and when you get that challenge, usually you just get a copy of the service, like the binary, and it tells you like what IP address and port that's running at, so you can reverse engineer it offline, and then you can try and run your exploit that you created in your lab, and download the key and submit the key to the scoring server. One of the issues they've had in the past, and that continued this year, was that it's not always intuitively obvious. Like for the Pwnables it usually is, because the key is usually in a directory. Like if the service runs as /home/tomato, that's the service name, then in that home directory there'll be a key file, and if you can read the contents of the key file, it's just like a, you know, like a whatever, MD5 sum or something, you can just submit that. You know you found the key, and that's good. So it's like, you know when you've solved the challenge. Some of the other ones, like some of the ones we'll look at, I was going to show you a couple real quick. If you're, you know, de-obfuscating some picture as a forensics challenge or whatever, there may be some string in there that's like, you know, go blow a goat or something. Like, you don't know if that's the answer or not. Maybe it is. You found a string that you can read in English. You think, hey, maybe that's the answer, so you try to submit it. Nope, that wasn't the answer. So sometimes, and that's been one of the complaints that some of the challengers had, it's not always obvious when you solve the challenge, which is kind of part of the challenge, I guess. And so that's a forensics thing. It's a lot of times they deal with pictures, or you know, you might get some download of an iPhone or an Android phone, and you have to like somehow decrypt it or de-obfuscate it or pinpoint a location that the phone was last at. Something like that could be, for example, for a challenge. The retro, they also had, this year they had a bunch of pwns, so they had pwns that were used, binaries that you had to reverse and exploit from prior years. The grab bag was all kinds of different stuff. I don't know them all. I mean, most teams never get to all, never get to see them all. They don't always all open up during the competition. It depends on how many open up based on what team solved what. So the first team to solve a challenge, their tradition was you would get to choose what question opened up next, kind of thing. I don't know if they did that this year or not, or if they just automatically opened another one, but It's always something like that. And the grab bag could be anything from, I remember there was one last year where there was pictures of like people in the security scene, like Dave Eitel and whoever else, and you had to somehow like order them in order of lateness or some crazy thing like that. And of course, there's no way to like know what the lateness ordering is, so you had to like reverse this Java code using whatever tool and technique you could find and somehow talk to the server. I don't remember all the details on that one, but it was fun and kind of interesting and kind of different compared to some. So, okay, for this one I wanted to show, this was binary lateness, so I just wanted to show you a real simple one of the first ones you might get. So you get this binary program, and I don't know how I can do this without a wireless mic in terms of like talking and typing, but I can type one-handed, I guess. B1. So you're into binary lateness 100, and I've got a directory called clean. And so you just downloaded the first challenge. This is it. This is the binary that you got when you opened up this question. And the thing is, if you've never played these games before and you're not sure, like, what is the binary lateness category all about? Like, how do I solve this? What should I do first? Any suggestions? File, right. So that's for binary lateness especially. Like, what kind of file is this? Is it a picture? Is it an executable? So you take, and this is really challenging. How did other speakers do this? I didn't think about this until I got up here. File. So it's an ELF executable, so I could probably run it, right? So it's like, okay, well, I'm in the Linux VM here, and this looks executable. Hopefully it didn't hit me with malware or whatever. Oops, that's the issue. And it says if you run it with a 1 through 11 or all. So what if I run it with 1? It spits out all this crazy stuff. And you look at all this crazy stuff, if you can see it, it's actually like a giant smiley face kind of a thing. You probably can't really tell, but what else does that look like? Has anybody seen data that looks like that before? It looks like base 64 because it's a bunch of numbers, but they're all like ASCII. You can read them all. So it's probably some kind of binary data that they output as base 64 encoded information, okay? And if you do this for all the different numbers available, you find out it does the same thing. And if you recall, there was also this all option, and that outputs it like for all the choices, whatever this information is. We have no idea, right? But what if we take and base 64 decode it with the, by the way, when you're first getting into these challenges, if you don't know a lot about the command line and stuff, you'll have to stumble through all this, right? So you go, okay, I think that's the command, but it's like, oh, that sucks. It didn't like that, it didn't like that. So then you gotta figure out why, right? So you gotta go read the man page for base 64, or type base 64 -- help. And it'll tell you that if there's bad characters, you might also try using the -I option. And that works. Although if I output it, it'll output a bunch of binary in my screen and screw up my current console. I don't really want to do that, so I'll call it out. So now I have this file that I made called out. Well, is it just garbage, or what? Did it do anything? Did anything helpful happen? So if I type file again on out, I find out, oh, that's really interesting. File thinks that it's a gzip file. So apparently when I decoded it, and all of it put together is a big zip file. Okay, so how do I unzip it? And it's like, if I can type this off, unzip. But is this going to work? No, because it doesn't like that extension, right? So you got to change the extension. So you got to move out.gz. Really a challenge typing. Okay, so now you unzip it, and it's like, out is there again. So let's type file out. It's like, oh, okay, this is a 7-zip archive now. So this is really interesting. And this challenge is like that. They zip this like 100 times with different zippers. And so you have to like go through these hoops to try and get this thing to finally output something useful. 7, let's see if I can do it. I'll do a couple. I'm not going to do them all, right? 7Z out. it outputted a binary called bin2. And if I run that or do a file on it to see what it is, it outputs more smileys, which sucks. So it's like, oh, what do I do with that? You find out if you base 64 decode this one and output it, doesn't give you anything meaningful, which sucks. But I noticed that if you run strings on this binary, oh crap, let's do more. There's this weird string right at the very top that's a little different than some of the other ones, and so found out that if you give that string to it as an argument, it outputs different smileys, which you can base 64, and then you can unzip that. You can do this a whole bunch of times. So this challenge takes a little while. This one was easy, but it was like you had to be kind of persistent, and you had to know some tricks. So you get the sense that this is like the easiest challenge of the game. This was the 100 level challenge, and it took some time. So that gives you some sense for like how hard it's going to get as you continue on, right? It's going to get exponentially harder, basically, and from there. So then I listed out the majority of the commands that you had to. By the way, you notice I put a lot of like sudo app install lz out because they use like zip, algorithms that like don't come installed on boxes, because if they just use regular zip and stuff like that, that'd be too easy. They have to find these obscure zipping programs that nobody actually knows about or uses very often, stuff like that, just to kind of make it a little more fun. And those were some more commands that I had to run. And finally, I got to the point where I got it to output 3 different binaries. And they wouldn't do anything alone, but if you catted them all together, you could create one valid binary and then chmod it so that you could actually execute it. And then when you run that one, that was, let me just go, I think I have that one in the prior directory. That was bin3. And bin4. Oh yeah, that was, so when I finally got to the point where I built this last binary after going through all these hoops, it was outputting a bunch of junk, but it wasn't really, it's like, okay, well, that doesn't really look like this string, but this is an easy challenge. It's a 100 level, so I figured, I can throw it into IDA Pro and start reverse engineering this executable, which is a perfectly valid way to go. But I thought, well, let me just run strings on this one too, and just see if any interesting strings pop out on this one. Maybe we'll get lucky, since we've had to go through a million hoops already. And if you run strings, there's this one at the end. And again, some people don't like this about the challenge because you really don't know when you won, right? There's nothing that says you won. You can submit this key and score points now. And so if you're not a native English speaker, or you've never seen Back to the Future, which is where this quote comes from, by the way, that's actually the key. That's how you win this first challenge. So sometimes it almost takes a little bit of experience. I have 2 minutes left. It's hilarious because I'm like 10% through this talk. That's all right. What's that? I know. If anybody's ever taken the 2-day class I teach at Black Hat, it's kind of the same way. I cram 5 days of material into 2 days, which is kind of exciting. So I'll just bust through this one. I was going to show another example, the Forensics 100, and it was. It's actually a picture in kind of the classic forensics style. So if you look at the picture, it's just this. It was like 1,000 pixels long and 1 pixel high. So it's just a garbage picture. It's PNG. So you're like, as a forensics guy, you're like, crap. What do I do with this thing? Okay, it's just pixel data. Yeah. Yes, I want my Linux VM back. So. You can run file on it just like before if you wanted to. And what is it called? They all start with a long weird name, by the way, like forensics underscore and then some hash or something when you first download the challenge. I sometimes rename it. So you can see that it was, you know, like I said, it was basically 20,000 pixels long, 1 pixel high. You're like, okay. And so this is where, by the way, all over the hill hackers use Python. So if this is where you need to learn Python. So to be successful in any of these capture the flag events, you pretty much have to know Python or it's not going to work out for you. Because a lot of the solutions are best and most easily done in Python. This one I found, another team had actually come up with a solution that they wrote their solution in C++. But it's like 500 lines of code or something, right? Where the Python solution is like 10 lines of code for this particular challenge. So if you don't know Python, you probably want to learn it. So I started playing around. Let me just look at this plane. There's a way in Python that you can open an image using the image class, and then you can play with it. You can get the pixel at a certain offset. You can import that data into a different size container for that image. You can do stuff like that. And that's how this challenge basically ends up getting solved. Oh crap, I want to do more on that. So if I started looking at the pixel distribution, like, you know, is there any color pixel that shows up with regularity different than all the rest? And if you look through there, does anyone see a pattern that looks like more regular than like a good bowel movement or whatever, kind of regular in the morning? I don't know where that came from. It's this guy. You're giving me pressure. I'm feeling your pressure right now. I know I need to get off the stage. Anyway, the one that happens, there's a pixel that happens about every 450 places. And so if you resize the picture to be 400 pixels tall, that's where you actually get the solution to come out. And so if we just cap the solution on that, just to show you the code real quick. You basically just open the picture, and then you shove it into this 450 by 43. That's really all you have to do to solve this. The crazy thing is you never know that. So sometimes the actual solution itself is somewhat easy, but like, how did you know to do that is totally not easy, right? Sometimes you go down many rabbit holes before you finally think of that. Like, you may have been doing histograms on the pixels. You may have been trying to decrypt the pixels, thinking it's encrypted data, maybe steganography. Like, you have no idea. But somehow you got to the point where you're like, this is what I think it is, this is where I want to go. And if you actually run the solution, it resizes that same pixel and it pops up and says, thank you, sir, may I have another? That's actually the solution. Am I dead out of time? Okay, so I have more, but we'll have to talk offline. Do I get a minute for questions or no? No time for questions. All right, thank you very much.